Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
Okay, so for this problem, we have we have known the from the starting point to the end point. We know that the total time is capital T, and we also know that the power is a constant, so capital P. So the question is, if we have a different power, so from P to P plus dp, what will the time change? Okay, so to do this question, we need to utilize the definition of the power. So P, the power acting on this car, will be equal to F times V. F is the force acting on the car, and the V is the velocity of the car. And so that we can figure out uh, the force equal to P over V. And force according to the Newton's second law equal to m times a, where a is the acceleration. And so that uh, we can replace the a with dv dt, because acceleration basically is the derivative of the velocity. And now come back to this relation, p over v equal to m times dv over dt. Then we can move the v from the left hand side to the right hand side. Okay, so we will have and move this dt to the left hand side. Then we have a relation dt p times dt equal to mv dv, right? And then in this relation, we see that the p is a constant, m and the m is a constant, and we can do integral on both sides. So on the left hand side, the integral range is from 0 to capital T. And on the right hand side, the integral range is from 0, because initial there is no any velocity. And the final velocity we do not know yet, but we just assume this is Vf. Okay. So we have after performing this integral, we have P capital T equal to half m times Vf squared. This is basically the energy into the system equal to the change of the kinetic energy. So we can solve for this Vf, which will be equal to 2 pt over m and square root. Okay, so this is the final velocity. Uh, and then we also know that so we just assume that the total distance is capital S, but we do not know this S. However, we can just say that is S equal to integral from 0 to t and v dt, right? And we already know the relation between the v and the dt according to this relation, right? So we can basically replace the, sorry, this is small t, it's not capital T, it's a small t. So we can basically replace this dt with the with some formula in terms of dv. So this relation is because we're using dv in this time. So basically the integral range will be from 0 to vf and the v, and then the formula of the dt, which is mv over p times dv. Okay, so this is from this relation. And then we just do this integral. So m is a constant, p is a constant. We just move them out of the integral. M over p times 1/3 vf cubed. So this is the relation between the final distance and the power and also VF. Okay. So we can replace this VF with this relation, and I found it's 2/3 square root 2 square root P over M times T with power 3/2. Okay. So this is basically the relation between the total distance s and the power and also the total time t. So in this relation, we can do derivative on both sides. Because s is a constant in this problem, we do not, the total distance does not change, and p will change and t will change. M is constant, so basically we will have a new relation, but I do not have much room for me. So just right here. So basically the left hand side s is 0, and the right hand side we need to do the derivative on this expression. We will see that this is equal to 2/3 square root 2 and square root 1/m and 1/2 1 over square root p. So this is a p, and dp times t with power 3/2 plus square root 2. Right, this time we're doing derivative of p. So this is square root 2 square root p over m and times t with power half and dt. Okay, so this is a long expression, but we can already find out the final solution based on this relation, because if you look at this expression, we have dp in this term and we have dt in this term. So basically, we can solve the dt in terms of dp. Okay. So the final solution is I found is dt equal negative 1/3p uh, the numerator is t and times dp. Okay, so this is the final solution. It means that if the power is increased, then the time is decreased, which makes sense.